Good evening, dear participant, and welcome in this session on the Matlab tutorial series. Today, we are going to cover the topic differential algebraic system of equations. And in this lecture, we need some type of solvers which are inbuilt functions in the Matlab. All the content I have already prepared, and the PPT which is being presented in this session already has been sent to you in your WhatsApp group so that you can use for your practice on it. And good evening all the participants. Here is Vani Madhavi and Abhidami Tornyoy. Good evening all of you, and I hope some more participants will join us very soon. I think the content which we are presenting here are really very helpful for all of you. Today's session is very specific because there are several problems where we need to create the program, and this is the longest program which we present in the previous session. And in this session, there are only two examples has been selected to clear the concept. The solvers which we will use at this place are only two, and there will be one more special sessions for this type of solvers, how we can use for the system of equations or the ordinary differential equations. Then we have partial differential equations and many more. So this session will help you how the Matlab solvers help us to solve the different type of problems for the differential equations. So here you can see this is my desktop, and if you have any question you can put in the chat box. Okay, welcome Salahuddin and Anthony Ania. Okay, welcome in the session. And okay, I think you missed the last lecture. In the last session you was not available, and I am very happy to see again in this session. Luburn, good evening. Once again, good evening all of you. And as you can see my screen, the topic which we are going to discuss here is a symbolic mathematics toolbox for differential algebraic equation system. Okay, so here, yes, these are the agenda of the today's session. Differential algebraic equation. This is a very simple example and help you in many ways to understand the algebraic equations. Then we have the solve differential algebraic equation, how we can solve, and this will include several steps to solve the differential algebraic equations or differential algebraic system equations. Okay, and the steps which are involving at this place are presented with the help of example. In the third section you can see example of differential algebraic equations. In the very first step we need to specify equations and variables which are involving in the system of differential algebraic equations. Then we need to reduce the differential order, because when we have the system of differential algebraic equation, it may be second order or third order. So the first important thing is we need to reduce the order. It must be either zero order or it must be first order. Only then we can solve the system of this type of differential algebraic equations. After that, we need to check the reduce the differential index, and in the first step we will convert differential algebraic equation systems to the Matlab function handle. And in the step 5, we need some initial conditions for the solvers, and only then we have the specific solution. And at the end, last step we have is 6, which include solve differential algebraic equation using ODE 15I. So this is the ODE 15I is one of the Matlab solver, and in this example we will use ODE 15I, which is the inbuilt solver, and this will help you to understand other solvers also. In the place of ODE 15I, you can other solvers which are inbuilt functions. And in the more detail, we will discuss all these in the coming sessions. But the thing is, all the sessions are organized in step by step. And if you miss any session, then you will face the problem, because the thing is, every session depends upon the previous session. So there is connectivity between each session, and if you skip, then this will be problem for you. Also, the recordings of each session is available on the YouTube whenever you feel free, or if you skip or miss any session, you can go to the YouTube channel, which is you can easily find out this YouTube channel on YouTube by searching MathTech Thinking Foundation. And there are several playlists, and this is the playlist. You can find out all the sessions which are organized in one specific playlist, which is Matlab tutorial series 2023. You can check this tutorial series, and all the sessions are organized there. Okay, so if you have any question, please feel free to put your question in the chat box. Dennis and Jyotsna ma'am, Jacob, Amur, thank you to join this session. And once again, good evening all of you, and to join this session. If you have, once again, if you have any question, please you can put your question in the chat box. I will try to justify your question. But today, the thing is, the examples which we choose, second example, very long. So I already prepared the code in the presentation as well as in the Matlab, so that I can cover these two things in the single lecture. But the thing is, just you need to understand the syntax so that we can quickly cover this topic. Thank you. And also, one important thing, please don't leave this session. This will help you in many ways in the coming sessions. Now, here we have very simple example for the differential algebraic equation. Yes. So we have this dz upon dt is equal to minus 2z plus y square. So here t is z is algebraic differential equation with respect to t, and here you can see y is algebraic function of z. Okay, so these two equations are representing differential algebraic equation. And along with, we are given at this place the initial conditions. You can see this is the initial condition for when t is equal to 0, z is 2, and y0 is equal to this value. We can have the different values. So what we have to do at this place? First, we will write these equations in the single script file, and after that we will use some solver to solve the differential equation. So how we can define for the algebraic differential equations? We have the function. You can see this is the first part of the Matlab code, and function out. These are the outing values which we need. After that, we will define the function differential algebraic equation, and this differential algebraic equation involves two variables. One is t and the other is y. Okay, so z is differential equation is function of t and y. Okay, so here also you can see z is function of t and y, and also uh, z is function of y and y is function of t. Okay, so how we can insert these two statements in the defined function for the differential algebraic equation? Out is equal to, use this bracket and end with this bracket. See this carefully. Very first, this is minus 2z and z is y1. Z is y1, and then we have y. This is the second variable. We denote second variable as this one. So this is we have we have z, and this is we have y. Okay, so minus 2y1 plus we have y2 square. Okay, and this is the second equation, minus 100, then log y2, here is y and y is y2. Okay, then we have plus 2y1 and minus 5. When you need the equation, this will be in this side, so minus 5, and then we need to end this function. So this is the function which we have created for the differential algebraic equations. So for these two given differential equations. Now we need the conditions. Okay, so check at this place. We are given these two conditions, and this one 2 and 0.99005, but at this place we have changed the value. Yes, so now we need to apply, to solve the system, we need to apply the given conditions and the solver. Okay, so these are the initial conditions, 2, and this is the second condition. In the place of this value we change when we have y0 is equal to 0.99005. In this place we are using this value, which is 1.2339. Whatever the conditions you are given, you can choose accordingly. And after that, we are using space time. Okay, t span is equal to 0 to 1. This is the range of t. Okay, and you can see here is ODE 15s. This is also one of the example of the solver. There are several solvers, as I told you, that ODE 15s is there, ODE 45 is there, ODE 15 is there, ODE 15i is there. So here we are using ODE 15s. Now this is the syntax to use. So the solution will be in terms of t and y. Okay, so here is t, and at its place y, we will get these two values, and after that ODE 15s. So here is we are handling the function at its place at the rate diff al equation. We call at this place the function. We are calling the function which is diff al eq, which we created in the previous file. You can see we save the function with this name dot m. So all these equations will be called at this place by using this syntax. Then we have the t-span. So this is the time interval which we give at this place. This will be used, pass at this place. And this is the condition. These are the initial conditions. You can see this is the initial conditions. So now when we execute, this will return us the solutions, but we want to plot the system of solution. And what we are doing here, plot function is there. T is the range for, this is the first function, y1, and then t, this is the second function, y2. Okay, if you have attended the previous lecture on the matrices, then I think you know about this, because when we have the solution, this will create the matrix for the y1 variable and y2 variable. Okay, so all the values will pass at this place, and this represent the y1, and 2 is representing here y2. Okay, there will be two solutions. So when we will execute this file, then we will have the graph of the same problem. Okay, so we can see in the Matlab. Come to in Matlab. Here is just 1 minute. I have to open. Okay, these are the algebraic equation. Yes, this is the first example, and we can open this file and this file. Okay, you can see here very carefully. So we have to create two files. One is for the differential algebraic equations. You can see this is the differential equations, and the function has been created at this place. Okay, the code is same as you can see in the presentation, and at this place for the numerical results and to solve and to apply the conditions, we are using differential underscore call file. So the separate file has been created at this place, and the conditions are applied at this place. You can see y naught 3 and 0.5. At the place of 2, I have changed this value. Yes, it is 2, and this value was I think I have to check. The value was 1.2339. 1.2339. Okay, so we need the result for this one, and the interval was 1. The interval for t is, our range of t is, we have 0 to 1. Okay, so now and this is the same as we discuss at this place. Yes, you can see all the codes are same as we discuss here in the Matlab. There is no difference. The same code, with the help of the same code, we create two files. One is including the algebraic equations, differential algebraic equation, and second is for the initial conditions and function handle to solve the system of equations, and this statement will plot the graph. So when you will run this code, you can see we have the corresponding graph. Okay, and if you want to use at this place legend and grid on, we are using here legend. Okay, this is the legend function, and this is y1. This is y1. Okay, and second is y2. You can choose. You can change accordingly your choice. Okay, this is y2, and then you can grid on also. Grid on. Again, run this code. Yes, you can see y1, this is the differential equation, rate of change, and this is the graph of the differential equation, and this is the for the algebraic solution. Okay, so this will represent the dz upon dt, and this will be the equation. So these are the solutions of the differential algebraic equation. In this way, you can easily get the solution. Jasprit ma'am, good evening. Nidip Monk, Jacob, good evening all of you, and welcome in this session. Okay, so this was the simple one example for solving the differential algebraic equation, and the code is very simple, which has been provided in the presentation which I shared with you in the WhatsApp group. Okay, the next example which we are going to present here is a very one dynamic example, and there will be several steps in this example, and please don't break the sequence. You need to follow each step, and only then you will be able to implement for your problem. So in this example, you will establish the equations, then you need to find out the conditions also, and after that you will be able to write the program. But the most important thing is you need to verify each step. Only then you will be able to write smart code. And I hope this sequence of steps which I have included at this place will help you in many ways. So come here. You can see when we have the differential algebraic equation involving various functions and state variables like xt is equal to, we have x1, x, f we have the form in this form, f t, xt, and x dash t. T is independent variable, and the number of equations which f is include, f1, f2, and fn must be match the number of state variables. You can see here are n functions, and here are we have n equations. These both must be matched. Only then we are able to find out the solution of this type of problem. Okay, and also because most of the differential equation, differential algebraic system are not suitable for the direct input in the Matlab solver, such as which we are going to use ODE1. First, we need to convert them to a suitable form by using symbolic math toolbox functionality. And this functionality, what will do, this will reduce the index of differential algebraic equation either 1 or 0. Only then we will be able to find out the solution of this type of problem, and then we can convert the differential algebraic system to numerical function and as suitable for Matlab solvers. Okay, and these are the main steps which will include to solve differential algebraic equations. And here are some solvers like ODE15, ODE15S, which we use in the previous example, and also there is ODE23T to solve the differential algebraic equations. You can use one of these solver to solve the differential algebraic equations, because there are many solvers, but you need to think which solver is suitable for your existing problem, and this will take time. to understand what are the syntax, what are the equations, whether it is algebraic, differential algebraic equations, and many more. So accordingly, you have the problem. You need to choose the particular MATLAB solver to solve the differential equations, whether it is initial problem, whether it is a boundary value problems. So this will help you how you can use the solver. In the previous session, the solutions which we find out was analytical solution with the help of MATLAB. But here the solvers will always provide us the numerical results which are approximate. So these solvers are based on numerical methods or approximation methods like Gauss elimination. Then we have Rangata method is there. Okay, so this type of numerical methods are used to create this type of solvers, and even you can also write your own program to write or to create this type of solvers. And also if you have sound knowledge about numerical methods, then you need not required to use these solvers, because these solvers will help you to use directly. These are inbuilt functions in the MATLAB. If you don't have any solver, then what you will do? You need to apply numerical approach, and there are some other methods. Okay, so these solvers are based on numerical approach. Okay, so now when you are thinking about a differential algebraic equation system and to solve it, then these are 6 steps. In the very first step, you need to specify equations and variables which are involving in the differential algebraic equation system. Then we need to reduce differential order because these solvers will be applicable only if you have the first order differential equations or zero order. So higher order, in the case of higher order, you are not able to apply these solvers. Then in the third step, check and reduce differential index. And in the fourth step, we will convert differential algebraic system to the MATLAB function handle as we do in the previous example. Okay. And in the fifth step, we need to find the initial conditions for the solvers. Sometimes in the previous example, we have already given the initial conditions, but sometimes if we are not given the initial conditions, then we need to find out which conditions need to apply. Okay, so we need to find the initial conditions, and in the sixth step, we will use ODE 15I to solve the differential algebraic equations. Okay, and by using this step, also we will check each step and their corresponding value. I have this presentation along with the MATLAB code is ready. So we will verify MATLAB code also, and if it is required for your use, I will try to share this MATLAB code also. Otherwise, you should use the syntax which I have provided in this presentation, because there is no difference between the script file which I have created. Okay, so I think you must create your own script file so that you can understand how you can write the MATLAB code. You can save when you will create your own script file, then this will help you in many ways for the coming sessions also. So I think I should not share this script file. You should write your own script file which on the basis of the content which I have provided in this presentation. So here we have this example. So this is the differential algebraic workflow for solving the differential algebraic equation for the pendulum, and you can see there are, this is the position of the pendulum at time t. Okay, so the coordinate here will be xt and yt. This is the position of the pendulum at time t, and this is the x-axis, and on this side we have y-axis, and its weight will act vertically downward. Mass of this pendulum is m, and this the tension will act along in this direction, and the length we have is r. Okay, so r is the length, and there are several parameters. One is m, second is r, and third is g, which is constant. Okay, and this motion will be like in this way. Okay, so now position is yt, and the force which is preventing pendulum from the flying away is t. Okay, so this is the tension in this rod or the string. Okay, so tension will act in the towards the fixed point, and also you need to resolve the parts horizontally and vertically at its place to write the equations of motions. So the equations of motions we have is, these are the variables m, r, and g. M is the mass of the pendulum, r is the length of the pendulum, and the gravitational constant is g. So this is the system of algebraic equations. So along the horizontal motion we have m d2 x upon dt square is equal to t xt upon r. So, and m d2 y upon dt square is equal to t yt upon r minus mg. How you can do? You can see, yes. So here you will resolve. Suppose this is the angle theta, and the resolving part, this is also theta. Okay, so in this direction the resolving part will be t cos theta, and in this direction will be t sin theta. Okay, and you can find out the values of cos theta, which will be we have value of cos theta. So this is xt. Sorry, this is xt, and this is yt, and this is xt. Okay, according to the position. So cos theta will be, we have cos theta we will have, you can calculate from this one. This will be yt, this will be t yt upon r, and this value will be, we will have t xt upon r. By putting the values of sin theta and cosine theta, you can easily calculate from this place. And then we have the system of equations, this one and this one, and also we have x square plus y square is equal to r square, because this is the one type of semicircular motion. Now to write these equations, we need to define the symbolic variables. So this system of equations involve xt, yt, and t. Okay, then we have m, r, and g. So the equations, these are the symbolic variables. First we need to define at its place xt space yt space t space m space r space G. So all the variables and parameters which are involving in our algebraic equations we need to define, and then after we can write the equations. Now there are several three equations. So this is the first equation, m dot diff xt. This is the second order differential equation, and this equal double equal sign is used for the equal. The meaning of this one is equal. So this is the assignment for the equation. So the first differential equation has been saved in this assignment. Single equal is used for the assignment variable, double equal is used for equal mathematically. So this is the first differential equation. You can see the syntax for this differential equation we have is this one. Notice very carefully, m diff is derivative and xt, this is the second order, is equal to t, then we have upon r xt. Okay. Similarly, we can write the second differential equation, which is m diff yt, and is equal to, this is equal to t upon r product yt minus mt. And this is the third equation, which is x square plus y square is equal to r square. So these three system of equations can be easily saved in single equations, okay, by using in this way equation 1, equation 2, equation 3. Okay, so these are the three equations, and after that we can easily place the state variable in the column vector and store the number of original variables for the reference which we required. So these are the variables xt, yt and t, and when you will execute original variables, this is the length of the variable. So when you will execute this statement, length of variables we have 3, x, y and this one. So this will return the value. You can see in the Matlab also. This is very important for the Matlab part. Okay, I have opened the script file. Yes, you can see here, this is the Matlab code. Yes, so all the statement which we are inserting here, we will verify. Also, you know, when we comment the statement, then this will not return the solution. Okay, so all this statement I am going to comment by using Control and R. So now we have these three equations. These are symbolic variables. So when you will write the Matlab code, follow these instructions. We are always use CLC, clear and close all. Then you will insert the symbolic variables xt, yt, t, m, rg, and always use space at its place. And these are the same equations. And then after these are the variables, and I comment, uncomment, I have remove the semicolon. So this will return the value when I execute this file. See, you can see the value is 3. The meaning is that the system of equations are involving 3 variables and which we have defined at this place. This will help you in the coming slide. Okay, so here, yes, now we reduce the differential order, and this step is optional, but you can check where variables occur in differential algebraic system by using this statement, incidence matrices, and these steps find any variable that do not occur in your input and can be removed from the variable vector. Sometimes if you have additional vectors, then you can use, yes. Sir, in place of t, theta t, how do we define? The same manner you can define as we do at its place. The thing is, first follow this script file, and you need some experiments. Don't run this file speedily, but you need to understand the each syntax. When you will understand this file, then you can change the variables, you can change the syntax, you can change the differential equations, and you will able to understand how you can define the symbolic variables. So in the very beginning, you need to understand all the statements, okay, and how you can create your script file, how this file will work. So when you will write this script file, you will check all these statement by uncomment the statement, okay. So you can see here I am using semicolon, okay. The meaning of if I will remove this semicolon and run this file, so you have this differential equation, okay. When you will remove this semicolon, now you will have two differential equations. You can see, okay. You have these two differential equations. This is the first differential equation, and this is the second differential equation in the Matlab syntax. And this is the third differential equation. Now do uncomment all these, Control Z, okay. And if you will use only this one, if you will uncomment this file, see, you will have the equations which is involving this is the first equation, then you have the second equation, okay, and this is the third equation, okay, and these are in the form of matrix, okay. So in this way you can check how the Matlab syntax which you are inserting in the script file and how these are working, okay. So this is very important to understand the syntax and the sequence of statements for the long program. And when you will be do experiment after experiment on one problem, then this will help you in many programs which you will write or which you need to for your scientific computing, okay. So this example will help you in many ways for the different type of examples to write your script file, how you can handle the problems, how you can insert the differential equation, or how you can create the differential equations, system of equations, and how you can store them in the single variable, and many things are there, okay. So now display the incidence matrix by using this one. So this will return the incidence matrix has a row of each equation and column for each variable, because the system has three equations, three state variables. So this will return us a 3 by 3 order matrix. Here is when you will execute. So here is x, here is y, and here is t. So when this is the first equation. So first equation we have x and t. Second equation we have y and t. Third equation we have x and t. So this will help us which equation is involved which variable, okay. So you can use this syntax in the Matlab in this way. This is the input, m is equal to incidence matrix, equations, and variables, and when you will execute this statement, this will return this matrix, as you can see, okay. And along with we have the Matlab also, and all these things we will check. Now you can see this is the statement. So all the statement will be suppressed because here is semicolon. So now I remove the semicolon from this place. Only the value of this statement will be in the command window, okay. So along with you will understand how you can uncomment or you can remove the semicolon, and only those statements will be returned in the command window after solving. Yes, you can see this is the M matrix. Okay, so the first column we have the x variable, second column we have the y, and third variable for t. Okay, so when you will choose first row, and in the first equation you can see here is x and here is t. Okay, and that's why y is not involving in the first equation. We have first at this place we have 1, means x is here, y is not involving, and t is at its place. And in the second equation you can see y, t and t. So x is not involving in this differential equation. So here is 0, and this is for y, this is for t. And in the third equation you can see there are only x and y. So here is x, here is y, and t is not involving in the third equation. So this is the main purpose for the indices matrix, and this will help which equation is involving the variable. And if a column here I have explained all these things. 0. If a column incidence matrix is all 0, then the state variable does not occur in the differential algebraic system and should be removed. Okay. So now, yes. Now, what do we do here? The differential equation of ordered differential algebraic system is the highest order differential equation. And to solve DAE using Matlab, the differential order must be reduced to 1. Note this point very carefully. Okay, but in this problem, you can see that first and second equation has second order derivative of xt and yt. So the differential equation order is 2. So first we need to reduce the order to 1. Only then we can find out the solution of this differential algebraic equations. Okay, so now how we can do? To reduce, we have this inbuilt function. Reduce differential order function will be used to reduce the order for first order system. And substitute derivative with the new variable such as dxt and dyt. So here the right side of the expressions in the equation is 0. Now how can do? See here equations, and these are the variables, and here we are using reduced differential order. The same function we are using at its place, and these are the equations, and here we have the variables. Okay, so when we will execute this statement, this will return these values. This will return, sorry, we have these values. Yes, so these are the differential equations, and these differential equations you can see here dxt t, and here is diff. Okay, and this is the second differential equation, this is the third equation, and dxt is minus diff, and this is the fourth equation. So the above equations reduces to in this form, and these are the equations after reducing the order, and then you can see these are the variables which will include in the above equations. So what about this one? This is the dxt. means first order derivative, and here is diff. It means this is the second order. Okay, so what we do here, come at this place. Optionally, to show the derivative corresponding to the new variables, call reduced differential order and 3 input argument to find the location of the new variables in the system. Use incidence matrix. We have to follow this step and check the reduced differential equation index. This is very important. When you will justify this step and note whether we are able to use the function holder or not. So what we need to check at is place differential index of the differential algebraic system, and using is low index DAE. This is the inbuilt function, and by using this one we will check, and if the order is 0 or 1, then A's index DAE will return logically 1, which is true. And you can skip step number 3, which we do already, and we can go to step number 4 and convert the differential system of equations to the Matlab function handles. Here is low index will return 0, which is false. If we have 1, it is means true, and if we have 0, then it is false, which means the differential index is greater than 1 and must be reduced to use the function handle or for solving the differential algebraic equations. So when we will check this one, is low index equations and variables, whether it is 0 and 1, and this will return logical 0, and 0 means this is false. Okay, so come to the Matlab so that we can verify each step. We have done this step. Okay, and yes, so when you will uncomment and execute this statement, you can see the same step which we discussed in the Matlab. Okay, so we have the reduced differential equations, you can see here, and all the variables which are involving in the system of algebraic differential equations we have. These are the variables. Okay, now I will comment this equation. After that, I am using semicolon to suppress the system. Now we want to check. Here is differential index of the system. So this function is used here to check the differential index, and when you will execute, see here is logical 0. This will return the value in this form, logical 0, and which is false. Okay, so what we have to do now? What should we do now? We must have this statement true. So here again I suppress the statement, and here come to at its place. So again we have to use the same reduced DAE index function to reduce the index. Okay, so to reduce the differential index of the DAE described equations and variables, we are using here DAEs. These are the differential algebraic equations, and this is the for variables. After reducing the index, the information will be stored in this assignment and in this assignment for variable, and this will be the first one will be the differential algebraic equations, and here we are using reduce DAE index, and when you will use this function, the order will be reduced, index will be reduced. Okay, so this is very important to reduce, and the order must be 1. Okay, so equations and variables, the above equations we will pass through this function. We have the equations and variables, and after reducing the index, these equations will be stored in this variable and in this variable. So when you will execute this statement, we have these equations. Okay, so you can see these are the differential algebraic equations, and some are on the next slide. Yes, so all these are above equations. Along with these equations, we have differential algebraic equations, and all these are differential algebraic variables. Okay, so here is xt, yt, t, this is the dxt, this is the dyt, this is the first order, this is also the first order derivative of y with respect to t, dytt, this is the second order derivative of y with respect to t, this is also the second order derivative of x with respect to t. Okay, so these are representing the second order, and these are representing the first order derivative, and these are the variables. Okay. And now, yes, often reduce the reduce DAE index, introduce the redundant equations. So we need to also remove the redundancy in the equations and the variables that can be eliminated by using this function. Okay, so reduce redundancies, this is the function for the differential algebraic equations and differential algebraic variables. Okay, and these will be stored in this variable. These are the assignments which will be used. So when you will execute, you can see that the equations has been reduced. Okay, in the previous you can see there are numerous equations, but here equations are reduced for the redundancies which occurred at this place. Okay, so these will be reduced, and these are the differential algebraic variables, and also you can compare what you get after using. These are also eliminated. You can check it. Okay, here you will not have like dxt1, dyt1, etc. So now we will again check the index of the new system which has been created by using the same function, and logical is 1. This will return, we will have logical 1, which is true. It means now we are able to use for the function handle, and if you need to check in the Matlab, we can check here at this place very frequently. All things are already prepared. When you will execute this statement, you can check these are the solutions. Okay, you can check here. Yes, and suppress it, and when you will use the reduce DA index, here is the corresponding solution, and now you can see we have this system of differential algebraic equations along with the variables which are involving, and also when you will comment this equation, suppress this system by using the semicolon and remove the semicolon. So when you will check it, you can see here is 1. It means now we are able, the system of the new system of equations is now true, and we can convert the system of algebraic equations for the function handle. Okay, now see how we can convert this system of equations for the function handle. Yes, come here. So The step function handles for the Matlab ODE solver, which we are using ODE 15I. Okay, and to use specialized mass matrix solver such as ODE 15S, or you can use also this one. So now reduce DAE output as a vector of the equation, differential algebraic equations. A vector variable in the differential algebraic equation variables. To use ODE 15, we need to function handle that describe differential algebraic equations and how we can do. See here, this step is very important for the above all the differential equation and how we can use the function handle. See, here we are using PDAES. Okay, so the equations in differential algebraic equations can contain symbolic parameters that are not specified the vector of the variable differential algebraic variables. Okay, so find these parameters by using set diff function. This is also the inbuilt function in the Matlab, and we will use this function on the output symbolic variables. Okay, this is the symbolic variables. When we solve the algebraic equations, we are returning some symbolic variables in the form of xt, yt, zt, then we have dxt, dyt, and so on. Okay, so here is PDAES symbolic variables which are involving in the differential algebraic equations, and you can see all these variables. These are the variables. Okay, and then we have the P differential algebraic equations, which are the these are for the differential algebraic equations. And sorry, just 1 minute once again. We have yes. So we have one is this differential algebraic equations, and then we have differential algebraic variables. Two things are there. Okay, so we have two equations corresponding to the above. Yes, so this is the for the differential algebraic equations, and this is for the differential algebraic variables, and both the equations are involving the M, G, and T. Sorry, R. Okay, so these are stored in this place, and extra parameters we are using here set differential equations. These two equations are involving some extra parameters which are G, M, and R. So we are using here set diff. So both these two equations are passed through set diff function, and when you will execute this statement, this will return us the extra parameters G, M, and R. Okay, you can verify in the Matlab. So here, yes, this is the equation, and when you will execute, comment this one semicolon. Okay, so now when you will execute, you can see these are the extra parameters which are involving in the above algebraic system of equations. Okay, yes, so I already prepared the script file so that we can solve all these. So now what we should do now? Yes, now we are able to create the function handle for the to use solver ODE 15, which is the general purpose of the solver, and to specialized mass matrix solver such as ODE 15S and ODE 2S, we can use one of them. So follow this step how we can do. Sorry, this has been discussed. Okay, this has been discussed already. Okay, this has been discussed. Yes. So now we need to create the function handle by using this function DAE FU function, and these are the variables like DAE differential algebraic equations. Also we have differential algebraic variables. There are several differential algebraic equations which are stored in this variable, and we have different type of variables which are stored at this place, and these are the extra parameters GMR, and we have created a single function f. Now the rest of the workflow is purely numerical, and we need to set the parameter values and create the function handle ODE15. This is very quite simple. We can assign the value of G, which is 9.1881, and value of M is 1 and value of R is 1, and here we create a function which is involving at the rate T, Y and YP, F which is T, Y, YP, G, M, R. Okay, so all the information will be stored in this function. Now, when after that we need to find out the initial conditions for the solver. Okay, and yes, so ODE 15I solver requires the initial values for the variables, and find the initial values that satisfies the equations by using Matlab DAEs function. This will help you to find out the initial conditions. DAEs accept the guesses which might not be satisfied the equations. Note this step very carefully, and this will help you in many ways to help to find out the values, initial conditions. Okay, so DAEs accept the guesses for the initial conditions and tries to find out the satisfactory initial conditions using guess. DAEs can fail, in which case must be manually supply consistent initial values for your problem if it fail. Okay, so first we will check the variable. You will use this statement, and when you will execute this statement in the Matlab, this will return all the variables. Okay, you can see all the variables at this place xt, y. Now yes, so here dxt and is the first order derivative of xt, dyt is the second order of yt. Okay, and these are 7 variables, 7 by 1 vector. Okay, these equations are involving. So therefore, guess for the initial values variable and their derivative must be of 7 by 1 order vector. This is very important, and because when we pass the values, the vectors must have same length. Only then we can easily find out the solution. Now assume that the initial displacement of the pendulum is 30 or pi upon 6, and origin, the coordinate as it the suspension point, the pendulum is given, and given also the used radius r is 1, the initial horizontal position xt is this one, and the initial vertical position we have for yt is this is the, these are the initial conditions for xt, for yt, for r, and the displacement. Okay, and specify the initial conditions for the variables of the vector y. So what we do here, arbitrarily set the initial condition of the remaining variable, the derivatives 0. These are not good guesses, however suffice for this problem in your DAEs error, then provide better guess and refer to the DAEs. So here we have the y0 set. This is the initial condition for xt, this is the yt, and these are the initial zeros for the rest variable. Okay, and yp reset is zeros 7 1 because the dimension of the vector is 7 by 1. Okay, so we will create zeros 7 by 1 so that we have all the initial values and the y parameters must have the same dimension of the vectors. Now, sorry, we are arrived at this place. Yes. So here we create the option set of the specifies numerical tolerance of the numerical search. Opt is equal to ODE set will be used. This is the real tolerance, which is 10 raised to power minus 7, and for the absolute values tolerance is minus 7. So find the consistent initial values of the variables and their derivative using the DAEs. So here is y0 and this is the yp0. DAEs function is there. F function we create and 0. This is the y0 est which we created in the previous, and pass the values. Then we have yp0 set will be created and pass, and then we have this optional input. So all these will create, we have some numerical values. When you will execute this statement, we have the values of y0 and yp0. So all these values will be created, and all these we have the numerical values and will be stored at this place. Okay. Then after we want to solve. We are arrived at the last step. We want to solve for the range of t 0 to 0.5, and t solution and y solution we will get, and we are using here the function handle for the differential equations. We have ODE15i. So we will pass all these values. We have the f function which is involving, see, note this step very carefully. Yes, this is the f function. Okay, this will be passed at this place, and also these values, okay, it will be passed, and also OPT. See here, see now, this is the range of t. We get the values of y0 in the previous slide. We get the values of corresponding yp0, and this is the OPT. So all the function ODE15 will be used in this way. Okay, note this step very carefully, and after that, this, when you will execute this statement, this will return the solution of the algebraic differential equations. Okay, now we can plot the solution will be stored in this variable and in this variable. Okay, so what we do here, t solution and y solution from 1 to original variables, and this is the sign. Okay, so all these will pass through, and after that we are using here, because the original variables, there are x, there is y, and there is t. Okay, so for k is equal to 1 to original variable, these original variables we have 3 variables. This is the xt, then we have yt, and then we have t. Okay, so first it will pass at this place, and it will generate the values and plot the graph. Then for k equal to 1, for Next value we have k equal to 2. The second graph will be created for y variable, and then we have the solution for third t. Okay, so the original variable we have these 1, 2 and 3. So 3 graphs will be plotted, and after that we are using here legend. Okay, a legend is used and grid on. Okay, so when you will execute this statement, this will return us the graph which you can see here. Okay, so this is the corresponding graph. Now check in the Matlab. Also, I skip many steps. Okay, so you can check here all these things. In the last we discussed about the parameters as additional. You can uncomment and check all these. Okay, so here when you will remove this semicolon, these are the variables which are involving in the differential algebraic equations variable. Okay, yes, and now after that these are the conditions which we applied. Okay, and if you want to check if you want to check any value corresponding to this, what are the purpose of to write these equations, you can uncomment and you can check all these. Okay, so when you will remove this semicolon, okay, you will have these values. These are the values which has been created at this place. Okay, similarly we have the values for yp0, and this is the just vector. Here we have the 7 values, and we have the corresponding to this one is also 7 values. So you will do all these things yourself. DAEs function is also used at the place. Okay, so now the thing is, this is the last step. This is the last step, and first we need to uncomment. Sorry. Okay, so now this is the code, and the function handler is there which will plot the graph. So when I will execute, when now when I will execute these statements and see, we have this beautiful graph. Okay, and after you can see the legend is there, xt, yt and t. Blue color is for the x is a function of t, y is also function of t, and t itself is a function of t. So blue is color for x function, and the second is for y function, and the last one is for t function. If you want to save this file in your format for your use, you press Ctrl S. Okay, and then after you will give the name. This is the figure 1, FIGURE1. Then dot, if you will use here JPG, then this file will be saved in JPG format. If you are using here PDF, then the image will be in the form of PDF. If you are using EPS, then this file will be saved in the EPS format. Or the other way, you can change from this place. There are several formats according to your choice. You can select any format. Like we have TIFF format is there, .png is there, PDF format is there. Okay, and .fig, this will be Matlab figure. So we are using .aps. So I would like to save this in the JPG format and then save it. So the file will be automatically saved in my current directory. You can see this is the file. Okay, and if you want to open, you can open this file The file will be figure 1. File will be saved in my directory. Differential algebraic equations is the second example. Yes, you can see this is the example. Yes, you can see this is the JPG format, and you can use this file anywhere. So, dear participant, this was all about the today's session, and I am very grateful all of you attend this session throughout without skipping the lecture. All the steps I tried to explain very carefully. If you have any question, you can put your questions in the chat box. It has been covered within 1 hour and 20 minutes took place. I thought it will take more than 2 hours, but due to the PPT which I have prepared and the syntax in the Matlab, it saved my time, and we covered the whole content within I think 80 minutes are enough. Now the thing is you will practice on it. This will help you in many ways, and the most important thing for you to understand the syntax and the problem, how we can write the system of equations after creating the differential algebraic equations, then how we can find out the initial conditions by employing if we are given, and some variables we don't have, and DAEs function is there in the Matlab to find out the other variables, and if there is any error, then this function will help you. So all the you have this presentation, and also I provide the YouTube link for the today's session in your presentation, which you get in the WhatsApp group. Also, I have one request for all of you. You must invite some more your friends, your colleagues, your student for their beneficial. And very soon I am trying to organize one-day workshop which will be on differential equations. So this will be face-to-face interaction. Very soon I will share with you the schedule for the same. Also, we have created one workshop on mathematical modeling, which is going to start on the 1st May, and I invite some more speakers from different institutes, and all the information will be updated on our website. Also, I have one more request for all of you. We are getting many questions or the request regarding to establish a local chapter for the foundation. This is a very quite a simple process. Just you need to write me. Either you can write through the WhatsApp, or you can communicate through my email address. And there are contact us @mtf.in email address on the website. You can contact anyway, and this will help you the local chapter of the student, because our objective and the aim of this foundation, the vision is that we want to reach each student. So the series is there, and there will be very soon several courses which we are going to start to help our new generation to prepare for the next generation. Technology play a very important role in the development of science and technologies in many ways, and there are many scholars and students, those people who are facing the prompts, but along with we need your suggestions, your feedback time to time. So the coming workshop which will be free available, and I invite you all of you to join this one day workshop. The link and the schedule for the same will be shared with you very soon. And also always try to put your questions in the chat box. I always try to share with you the presentation before starting the session so that you can go through, and also I will try to share the presentation at least one day before. Okay. Also, I wanted to, we are trying to upload some prepared lectures which will be available on the website of on the YouTube as well as on the some courses also. So thank you very much again to be part of this workshop.